Welcome to day 2 logarithms, and we're going to really use those rules of exponents from last class to talk about something called logarithms. But before we go into that, let's look at all these examples and let's figure how we could rewrite each of these numbers as a power of 10. So as you can see, 1,000 is 10 to the third. Well, a million would be 10. Well, I see 6 zeros. 10 to the 6. 1 over 10 is 10 to the negative 1 if you remember your rule of exponents. Again, remembering our rules, the square root of 10 is 10 to the half. A root is a fraction exponent. Another way to write this number, 0.01, is 1 over 100, which is 10 to the negative 2. Let's see, 100 is 10 squared. A cube root is a third. So, and this is in the bottom, so this is 2 times this is going to be 10 to the negative 2/3. And let's see, 1,000 we already said was 10 to the third. The square root we already said is a half power. So this is 10 to the 3 over 2. So let's rewriting all those numbers using a power of 10, remembering those rules of exponents. Well, now we're going to talk about something new today called log. You've dealt with logs before when you were in Algebra 2, and it is a special key in your calculator. If you look on the left side of your calculator, you will see this very special key. It is under the x squared key. As you see, it's right over here is x squared, and right underneath it is that log key. This is the key we're going to be using right now. So I'm going to do this calculator at the same time see the background. So I'm going to do log of 1,000, so the log key of 1,000. And we get that. I'll do the next one underneath it, log of 0.01. And my first two results are 3 and negative 2. I'm going to bring up the calculator, so I'm going to do some of these on the calculator. I'm going to do log of 1,000,000. I get that. The next one is going to be log of 1/10. I get that. And the last one is going to be log of the square root of 10. And those are my results. If you want to make that into a fraction, we can make that into a fraction. So this was 6, this was negative 1, this was 1/2, and then these last two I'm going to put into the calculator, and I get log of 1 divided by the cube root. Oops. Gotta go back. The cube root of 100. And I make that into a fraction. I get negative 2/3. And finally, the log of the square root of 1,000. And I'm going to make that into a fraction. I get this result. So I get negative 2/3 and 3 over 2. So all these ones I just did match the ones I did on top. So every time I did a log, it was the exponent on that base 10 that we did in the first set of examples. So let's put into our calculator log of 2021 and log of 1 over 2021. And we're going to do log of 2021 and then log of 1 divided by 2021. And if you remember rules of exponents, oh yeah, it's just negative. 1 over is always a negative exponent. So according to what we have this is 3.3056, and this is negative 3.3056. So if I wanted to write 2021 as a power of 10, it would be 10 raised to the 3.3056. About, there's going to be a round off error. And this would be 10 raised to the negative 3.3056 to get 1 over 2021. Because when we do log, it is the exponent on base 10. Because what we're seeing is that, 10 to the x and this log key, they are inverses of each other. That's why 10 to the x is above the log key in blue, because they are the total undo or inverses of each other. So we're going to use that idea to figure out, well, what is 10 to what power gives me 2? 10 to what power gives me 200, and so on and so forth. So I'm going to use my log key. So for this problem, I'm going to do log of 2, and when I do log of 2 in my calculator, I get 0.301. And when I do log of 200, I get 2.301. I'll talk about why that happens. When I do log of a half, I get, that's 2 to the negative 1. So I'm going to get negative 1 of log of 2, which is negative 0.301. 4 is just 2 squared, so log of 4 will equal 2 log of 2, which is 0.602. And this is 2 to the 1/2, so log of the square root of 2 will be 1/2 log of 2, which is 0.151 when you round it off. So how does this all work? This all works based on using that the log of 2 is equal to about 0.301. If you notice right here, 0.301, right here we get 2.301 because there's 2 zeros here. If I want to do log of 2 million, it would be 6.301 when you round up to 3 decimal places, because there are 6 zeros. So the idea is, going back to old time, that this 0.301 was the characteristic of the number 2, whether it was 2,200,000 or 2 million. And the 6, the number up front, the mantissa, is basically telling you how many zeros, how many decimal places, or how many numbers before the decimal zeros are there in that number. Okay, everyone knows that 2 raised to the 3rd is equal to 8, but there's 2 ways to look at it. That number 2 is called the base. The 3 is called the exponent or the power, depending on which way we're looking at it. If we first look at it as a power function, it's the base, x to the 3rd is equal to 8, and the way I would solve this would take its cube root. To undo something, to undo a power, I have to do a root, and when I solve that, I get x is equal to 2. That's looking at it as a power function, a base raised to a power. But if I look at it as a base with an exponent, and that's the way we're going to look at it now, how do I undo an exponential? So I have 2 raised to this exponential is equal to 8. And I understand x equals 3 because we talked about this already. But the way I'm going to have to solve this to undo this, I'm going to have to use a logarithm of the same base. So when I look at this problem, I'm going to rewrite it as 2 to the x is equal to 8. And to solve it, I have to use a logarithm. Well, if this is basis 2, I have to use a logarithm that has a base 2. And when I do to one side, I have to do to the other. And when I get all that, I have my log base 2 and my exponential base 2 cancel out. I have x is equal to log base 2 of 8. And we already know this is equal to 3. We've talked about this, that 2 to the 3rd is equal to 8. So I know this is equal to log base 2 of 8 is equal to 3. So what is a logarithm? A logarithm is something that isolates the exponent from the base. In other words, it solves for the exponent. And that's going to be the key. How do we solve for the exponent? We're used to having a power and taking roots and finding the base. Now we have to solve for the exponent. And this is what logarithm is going to do. So we're going to do everything in reverse thinking like we've been doing in the past, but in a different way. Okay, so we're going to work with logarithms. And a logarithm is the inverse of an exponential. So when I see these two problems right here, log base 2 of 8 is equal to 3, and 2 to the third equals 8. They basically say the same thing, but in reverse or inverse order. One is an exponential, one is a log. Obviously the one with the logarithm in it is the log form, and the one with the base raised to the third is the exponential form. So in other words, log base 2 of 8 is equal to 3 because 3 is the exponent on the base 2 that gives you 8 as a result. I call this method the curl. I start at the base, I curl to the other side, and I curl back. But it also works this way. I could do it this way where this is still the base, 8 is the number, and 3 is still my exponent. Let's not overthink too much. If I want to rewrite this form here, I'm starting at the base and I curl it and I get 3 to the fourth equals, and I curl it back, I get 81. Same here, I start at the base is 4 raised to the 1/2, I curl it back, and my number is equal to 2. That's how I take my log form and rewrite it as an exponential form. Okay, I'll show you a different way in a minute, but that's one way to do it. Another way is to go from my exponential form and rewrite it as a log. Well, this is still the base. 2 is still the base. So this has to be log base 2, and the number is 1 over 32, and when I curl it back, I get the exponent of -5. Again, I start at the base, so it's going to be log base 16, the number is 4, is equal to, when I curl it back, is equal to x. That one I'm not solving, I just have it written out as a general form, but this is what I mean. Another way to do it, I'll do in this page, I'll do this first one. Log base 3 of 81 is equal to 4. So that's a log form. The undo of a log is an exponential. So for me to undo this, I have to use an exponential. So I'm going to do 3 raised to. That's an exponential. When I do to one side, I do to the other. So I have 3 raised to the log base 3 of 81, and that's the idea, is that the exponential part of the log cancel out. I have 81 is equal to 3 raised to the fourth. Well, this is exactly what I had over here. That's another way to do it. So in general, I read this as log base b of x. Sometimes the base will usually be written there, but we have special keys on our calculator. One is just called the log key, and that's the common log that always has a base 10. That's the key that we were using earlier on the first page. The log key, that's underneath the x squared. And then I also have the ln key, which is right underneath it, and that's called the natural log because it uses a base e. E is called the natural number. So ln basically stands for the log of the natural number, or the natural log. And the idea of what's going on here is, why is there 10 to the x above it? Because 10 to the x is the inverse of a log, and e to the x, which we used before spring break, is inverse of the ln, or the natural log key. That's not an I, that's an ln. Okay, if you have a newer calculator, and most of you do, there is a special key on your calculator. They do have that log base key. If you go to the math and you move it down to A, it says log base. And I'll show you what I mean on the calculator. Okay, on the left-hand side here, you have the log key. Here's the log key, and we could just log of any number. Let's say 200. Remember I told you it's 2.301. I could do ln of anything, and there you go. But if you want to use a special key, so you hit the math, you move it over to A. I'm going to scroll up to get to that A. It's a lot quicker. You have that log base. You can put in the base. So our example was log base 2 of 8 is equal to 3. And it is. I'm not going to use that too often when I do my instruction. I'll use it once in a while, but it's not really going to be my special key I'm going to use all the time. I like just using the regular log key or the regular ln key. Well, here are some basic properties that you should know. If I curl this, I would get b raised to the 0 is equal to 1, and any number raised to the 0 is 1, and obviously b raised to the first is equal to itself b, and so on and so forth. B raised to the n is still equal to b equal n, and so on and so forth. But the idea is that when you have a log and a exponential next to each other and they are the same base, they should cancel out. So log base b and exponential base b cancel out. Other way too, exponential base b and log base b cancel out. That's the key. So we're going to go through some examples here. It's really just finding the exponent on everything. Some are pretty easy, some take a little bit of work, but when I see this first example, I see 4 zeros. There's a base 10. When it's not written, it's base 10. This is 4. I say 4 to the what gives me 256. It's 4. 7 raised to the what gives me 1. Well, that doesn't matter. It's got to be 0. This one with all the decimals, this is a little 10 here, so 10 to the negative 5 gives me that. Ooh, I don't like this decimal. Maybe I should rewrite this as log base 5 of 1/5. Oh, 5 raised to the negative 1 gives me 1/5. Oh, for this one, maybe if I did the square root of 8 is 8 to the 1/2. Oh, so this exponent has to be a half. Again, solving for my exponent, here's my base of 4. 4 to the what gives me 1/16? Well, let's see. 4 to the second gives me 16, but since 1/16 I know it has to be a negative exponent. 5 to the third gives me 125, but this is 1/25, so it has to be a negative exponent. This is a little bit harder. I'm going to have to think about this. Well, 4 to what power gives me 2? Well, 4, the square root of 4 gives me 2. So that's going to be the half power, but it's 1 over that, so it's negative 1/2. Oh, look at this. This is when I want to talk about the same bases. ln is base e, so I have ln and e next to each other. They cancel out, I get a 2. This is the same idea. This is an e, so the exponent on this e is 1/3. And again, here's my e, and the exponent on this e is negative 2. E to the negative 2 is equal to 1 over e squared, and e to the 1/3 is the cube root of e, and so on and so forth. Again, maybe this one a little bit harder. I have to see 8 to what power gives me 2. Well, remember 8 to the 1/3, so this should be 1/3, but it's 1 over 2, so it's negative 1/3. And this is what I mean by a logarithm and exponential next to each other. This is base 10, this is the base 10, I get a 3. Ooh, this is not a base 10, but I can rewrite this as 10 squared and x plus 7, and now I have log of 10 squared x plus 7, and the log and the 10 cancel, and I have 2 times x plus 7, so 2x plus 14. These are the same bases, they cancel out. There's a little 1 here, so these are the same bases, I get a 1. These are the same bases, I get a 2.7. That's so great. When you have a logarithm and an exponential next to each other, they will cancel out. ln and e cancel out. Maybe it's better to say e to the 1/2 is the square root of e, so this is a half. And it doesn't matter, even when it goes the other way, exponential comes first, they still cancel. 10 and log are the same base. I get 2x. E and ln are the same base. They cancel, and e and ln are the same base, and they cancel. So these are some basic rules of exponential. So we're going to do some very basic solving. I like to solve using the curl method. My curl method is that I start here at the base and I curl to the one side, so I get 5 to the x equals, and I curl it back, I get equals 25. I know that 5 to the x is equal to 5 squared, so x equals 2. So log base 5 of 25 is equal to 2 because 5 squared is equal to 25. Or if I wanted to, or I could use the whole exponential number raised to exponential. So another way to write this problem would have been, let me rewrite it as log base 5 of 25 is equal to x. That was the original problem. If I want to use this whole number raised to, well, this base is 5, so I have to do 5 raised to, and when I do the one side, I have to do the other side. So 5 raised to the log base 5 of 25 is equal to 5 raised to the x. These cancel out. I get 25 is equal to 5 to the x. X equals 2, which I said before. It's up to you, whichever way you want to do it. I'm going to curl this. I get 4 raised to the third is equal to, I curl it back, is equal to k. K equals 64. Like I said, I like curling things. I get 3 raised to the negative 2 is equal to, I curl it back, m, which is going to be m equals 1 over 3 squared is equal to 1 over 9. If I curl this, I get n raised to the fifth equals, I curl it back, I get 32. To solve this, I have to root it. I have to take the fifth root on both sides. I get n is equal to 2. Maybe this is a little bit more work, but when it says log and there's no number there, I know it's base 10. I'm still going to curl it. I get 10 squared is equal to x plus 2. 10 squared is 100 equals x plus 2. X equals 98. There's a little e here, so when I curl this, I get e to the third equals, I curl it back, y minus 3. I'm going to add 3 to both sides, and I get y equals e to the third plus 3. I have no idea what that is, but I typed it in my calculator, and I get this decimal number. This one I'm going to curl. I get 4 to the 0 equals, when I curl it back, 6m plus 9. Well, 4 to the 0 is 1, is 6m plus 9. Subtract 9. Divide by 6. I get negative 4 thirds is equal to m. And this last one is the only one that I actually have to do some work. When I solve, I should try to isolate this logarithm. Basically, it's like saying this is 5y minus 2 is equal to 3. And I would solve for y. Well, when I solve for y, I would add 2. 5 log base 2 of 10 minus 4x is equal to 5. I would divide by 5. I have log base 2 of 10 minus 4x is equal to 1. And I could curl this, or actually I'm going to try the other method for it. So let's just show you something different. I'm going to do 2 raised to, 2 raised to. You know, it's the same thing as curling. It's just a different way of writing it. These cancel. I have 10 minus 4x is equal to 2 to the first. And 2 to the first is just equal to 2. I'm going to subtract 10. I get negative 4x is equal to negative 8. And I divide by negative 4. And when I'm all said and done, I can move this. I get x is equal to 2. That was a little bit more, but the whole idea was isolating that logarithm all by itself by getting rid of the minus 2 and multiplying by 5.